April 26, 1986. It's just after midnight. You're sitting inside the control room of Reactor 4 at the Chernobyl Nuclear Power Plant. The room smells faintly of warm electronics and machine oil. Panels of blinking lights stretch across the walls. Dozens of switches, meters, and gauges quietly hum as they track the heartbeat of one of the most powerful nuclear reactors in the world. You've been here for hours. Tonight is supposed to be routine, a simple safety test. At least, that's what everyone believes. Outside the plant, the small Soviet city of Pripyat sleeps peacefully. Nearly 50,000 people are resting in their apartments, unaware that their lives are about to change forever. Inside the control room, however, things already feel slightly off. The reactor power has dropped much lower than planned. Too low, one of the operators mutters under his breath as he checks the numbers again. Something isn't right, but the test has already been delayed for hours, and supervisors want it completed before the morning shift arrives. So instead of stopping the experiment, you continue. Slowly, control rods are pulled out of the reactor core. These rods normally absorb neutrons and keep the nuclear reaction stable. Removing them increases power. At first, everything seems fine. The reactor begins climbing back toward operational levels. But not everyone in the room feels comfortable. Some operators exchange quiet glances. The power level is unstable, jumping unpredictably. Still, the test must go on. Orders are orders. You glance at the massive reactor diagram glowing on the wall. Hundreds of fuel channels deep inside the reactor core are producing heat as uranium atoms split apart in a controlled chain reaction. Normally, this reaction is carefully balanced. But tonight, that balance is slipping. The reactor is now running in a dangerously unstable state, and most of the safety systems have been disabled to allow the experiment to continue. One of the senior engineers stands behind you, watching the gauges closely. He's calm, too calm. He insists everything is under control. You want to believe him, but something about the numbers on the screen makes your stomach tighten. Then the next step of the test begins. The turbines are shut down. Normally, when a reactor shuts down, emergency systems immediately activate to stabilize the core, but tonight those safeguards have been intentionally turned off. This test is supposed to measure how long the spinning turbines can continue generating electricity after shutdown. It's meant to help power emergency cooling pumps during a blackout. But no one expected the reactor to be in such an unstable condition during the test. The turbines begin slowing down. You hear the deep mechanical whine of massive machinery losing speed. As the turbines slow, water pumps connected to them also begin losing power. Less water flows through the reactor core. And water is what keeps the fuel from overheating. Suddenly, warning lights begin appearing on the control panel. 1, then 2, then 5. Steam pressure inside the reactor is rising. Rapidly, the room becomes tense. Someone calls out numbers across the control room. Another operator slams a button, trying to stabilize the system. But the reactor isn't behaving normally anymore. Inside the core, something dangerous is happening. As water turns to steam, it creates empty spaces around the fuel rods. In this particular reactor design, that actually increases the nuclear reaction instead of slowing it down. More steam means more power. More power creates even more steam. The reaction begins feeding itself. The reactor power suddenly surges. 10 times normal levels, 20 times, 30. The numbers on the panel no longer make sense. One operator stares at the screen, convinced the instruments must be broken, because the alternative is unthinkable. The reactor is running out of control. Someone shouts across the room, "Shut it down!" You reach for the emergency button, the AZ5. This is the reactor's final safety system. Pressing it will insert every control rod back into the reactor core, stopping the nuclear reaction instantly. Your hand slams the button. For a moment, nothing happens. Then the control rods begin lowering into the core. Everyone waits, hoping the system will stabilize. But something inside Reactor 4 is already too far gone. Deep within the core, a design flaw hidden for years is about to turn a shutdown command into a disaster. And within seconds, the most dangerous nuclear accident in human history will begin. Seconds after pressing the AZ-5 emergency shutdown button, the control room falls into a strange silence. Everyone expects the reactor power to begin dropping. That's what the system is designed to do. But the gauges on the panel are doing the opposite. The power level is still rising, at first slowly, then faster. One operator leans closer to the instruments, convinced the readings must be wrong. Reactors aren't supposed to behave like this, but the numbers keep climbing. Inside the reactor core, the control rods are finally descending. Long, graphite-tipped rods sliding down into the heart of the reactor. They are supposed to stop the nuclear reaction. Instead, something catastrophic happens. Because of a design flaw hidden in this type of reactor, the graphite tips briefly increase the nuclear reaction before reducing it. For a few seconds, the reactor becomes even more unstable. Power surges violently. Inside the core of Reactor 4 at the Chernobyl Nuclear Power Plant, temperatures skyrocket beyond anything the reactor was ever designed to handle. Fuel rods begin deforming. Cooling water flashes instantly into superheated steam. Pressure builds rapidly inside the reactor. In the control room, alarms start screaming. Lights flash across the entire panel. Someone shouts numbers that don't make sense. The reactor is now producing hundreds of times its intended power output. No one in the room has ever seen anything like this. Then, a deafening bang shakes the entire building. The floor jumps beneath your feet. For a moment, everyone freezes. No one speaks. Dust falls from the ceiling tiles. Someone whispers the words no one wants to believe. The reactor exploded. But that can't be possible. Reactors aren't bombs. They're built with massive steel and concrete containment systems. There's no way the core could explode. At least, that's what everyone has always been told. Then the second explosion happens. This one is far more violent. The entire control room shakes like it's being hit by an earthquake. Outside, the 200-ton reactor lid is blasted upward into the air. Concrete slabs shatter, steel structures tear apart, and the roof of Reactor 4 is blown completely open. The core of the reactor is now exposed to the night sky. A pillar of glowing radioactive debris shoots upward like a volcanic eruption. Chunks of burning graphite rain down across the power plant. From the windows of the control room, you can see something impossible. A bright blue glow rising from the destroyed reactor. This eerie light is caused by intense radiation interacting with the air. But no one here fully understands that yet. Inside the control room, confusion spreads rapidly. Some operators still believe the reactor is intact. They assume the explosion must have occurred somewhere else in the system. Maybe a hydrogen tank. Maybe a turbine. Because the alternative would mean something unimaginable has happened. But when workers run outside to investigate, they see it. Where the reactor building once stood, there is now a burning crater. The reactor core is completely destroyed. Radioactive fuel and graphite blocks are scattered everywhere. And invisible radiation is pouring into the atmosphere. Within minutes, the radiation levels near the reactor become lethal. But almost no one realizes the danger yet. Emergency crews are called. Firefighters from nearby Pripyat rush toward the plant. They arrive expecting a normal industrial fire. None of them are wearing radiation protection. They climb onto the reactor building roof to extinguish burning debris. Some of them pick up strange black chunks scattered across the roof. They don't know these pieces are highly radioactive graphite from the reactor core. Within minutes, the radiation begins destroying their cells. Many of the firefighters will later suffer severe radiation sickness. But right now, they focus only on putting out the flames. Back in the control room, chaos continues. Phone calls are made. Supervisors demand explanations. Some officials refuse to believe the reactor core is gone, because admitting that would mean acknowledging the worst nuclear accident ever imagined. Meanwhile, radioactive smoke rises thousands of meters into the sky. Wind currents begin carrying radioactive particles far beyond the Soviet Union. Over the next several days, radioactive fallout will spread across large parts of Europe. But at this moment, most people in the nearby city are still asleep. In Pripyat, families wake up the next morning unaware that they are breathing contaminated air. Children go outside to play. Workers head to their jobs. From a distance, many residents can even see the strange glowing reactor in the night sky. Some think it looks beautiful. They have no idea they are watching one of the worst disasters in human history. It will take nearly 36 hours before the city is evacuated. By then, thousands of people will have already been exposed to dangerous radiation levels, and the exclusion zone surrounding the reactor will remain largely uninhabitable for decades. Back inside the ruined power plant, the truth slowly becomes clear. The reactor didn't just malfunction, it was completely destroyed. A chain of small decisions, a flawed reactor design, and one routine safety test combined to create a catastrophe no one in the control room ever imagined possible. And as the sun rises over the shattered reactor of the Chernobyl Nuclear Power Plant, the world has just entered a new era. An era that proves even the most powerful technology ever built by humans can fail in ways we never expected. Because history's worst disasters rarely begin with explosions. They begin with ordinary nights that suddenly go very wrong.